Traditional materials resource planning, MRP, and distribution resource planning, DRP, have evolved into more advanced ERP systems such as SAP, APO, and others. With SKU proliferation and shortened lead times required by the market, replenishment-based systems such as Lean have also evolved. And despite continuously improving forecasting methods and software, the conflict between consumption-based execution and forecast-based planning has led to increasing undesirable effects which are present to some degree in most companies. Despite the pressure to produce and distribute for the market in an orderly manner, in many situations there is too much expediting, work in process, and unsold finished product. In many companies, due dates are often not met for all products, lead times are too long, there are too many stockouts along the supply chain, and the use of spreadsheet-based solutions is widespread as a supplement to ERP and other IT systems. A logical cause-effect analysis of these problems can be structured as follows. Companies want to maximize their performance and must be efficient. To control costs, companies want to produce and distribute without materials and resource waste, and also companies want to achieve high productivity and quality without stockouts or excess stocks. In order to do all this well, companies need to effectively plan, strategize, and identify potential problems in their supply, production, and distribution chains. Companies need to optimize their production and distribution resources, increasing their capacity utilization and productivity, and so make plans based on various forecasting tools to do this. Companies also need to ensure supply of necessary materials and components and finished products, and order from suppliers based on various forecasting tools. Because of all of this, companies feel pressure to make their operating environment more predictable and controlled. ERP and other similar systems are implemented using sophisticated advanced planning and optimizers, APOs, with advanced forecasting and MRP, DRP tools. The other side of this situation, which exists in current reality, is related to market and profit. Companies want to maximize their performance. To increase profits, companies want to continually increase total sales and throughput or value added, and companies also want to protect their throughput and profit margins. Therefore, companies need to be highly responsive to market opportunities and changes in demand. And since actual consumption is the only accurate demand signal, and since demand forecast variability is continuously increasing in today's markets, companies feel the pressure to disregard or eliminate or change their formal planning rules or manually bypass formal planning or otherwise rely on pull-based operational tools such as Lean, Kanban, supermarkets, or replenishment approaches. Therefore, in this situation, companies often switch between incompatible modes of operation, which results in huge amounts of waste, conflict, and expediting. And since push and pull modes of operation are incompatible, then we then see all the undesirable effects in the market. And no matter how sophisticated new improved forecast-based systems evolve, they do not solve the problem. In fact, better companies generally have to resort to frequent coordination meetings between sales and operations in order to adjust the projections for at least the principal SKUs in order to ameliorate some of these problems. However, a revolutionary approach to solving this chronic conflict is presented in the third edition of Joe Orlicky's Materials Requirements Planning, published by McGraw-Hill. In this edition of the MRP Classic, co-authors Carol Patak and Chad Smith present demand-driven planning as the solution to the conflict between push and pull logistics, which also underlies the major conflicts between sales and operations. The logic of this solution is explained in a future reality diagram. The bottom part of the logical diagram, the root causes and first effects, remains unchanged. Then, moving up a level in the cause-effect hierarchy, if companies need to effectively plan, strategize, and identify potential problems, and since demand-driven planning positions buffers considering customer tolerance time, market potential, lead time, supply and demand variability, inventory flexibility, and matrix bill of materials, supply and distribution network structure, and critical resources, and also develops buffer profiles and levels which ensure a supply of necessary materials, component, and finished goods. If this is done, companies are able to strategically select and position buffers to compress lead times, dampen variability, and reduce the bullwhip effect in supply chains, better leveraging working capital, the position part of the solution. On the other hand, companies need to be highly responsive to market opportunities and changes, and since actual consumption is the only accurate demand signal, and if actual consumption and qualified future consumption spikes are made part of the company's dynamic buffer adjustment practiced in demand-driven planning, then companies are able to adjust and replenish buffered position based on actual consumption and qualified planned spikes, resulting from seasonality, promotion, SKU launches and withdrawals from the market, etc., the pull part of the equation. DDP, demand-driven planning, thus permits strategic buffer positioning and dynamic buffer management, eliminating the conflict between push and pull and sales and operation. And if shared color-coded buffer status reports create shared priorities and collaboration, and the 5 position and pull components of demand-driven planning for materials and distribution requirements and the conflicting modes of operation created by push and promote, then companies can produce for the market in an orderly manner with little expediting, low work in process, and minimum unsold finished product, due dates which are always met, lead times which are the shortest in the industry, stockouts rare, and routine use of spreadsheet-based solutions almost non-existent. The 5 position and pull components for demand-driven planning and execution are strategic inventory positioning, buffer profiles and level, dynamic demand-driven automatic adjustment of buffer sizes, demand-driven planning, and visible and collaborative execution. For information on your next step in demand-driven planning, including a free opportunity snapshot evaluation on your company, contact Eric Bush at Demand Driven Technologies, ebush at demanddriventech.com. Thank you very much.